Unit 2 Chemistry, Chapter 14, Part 2, Measuring the Concentration. So we can give a numerical value to how much solute is dissolved in the solvent, and we can do that in a number of different ways. The concentration is the relative amount. So if we talk about a solution being concentrated, we mean we've got a lot of solute in a relatively small amount of solvent. A dilute is the other way around. We can either measure it in mass per volume, so the amount in mass that we've got, which is dissolved in a certain volume of it, or we can measure it in mole per volume. Okay, normally we use mass for mixtures and mole if it's a pure substance, but it does vary depending on how we'd use it. So if we want to find the concentration in grams per litre, very simple. You take the mass of what you're dissolving, divide it by the volume in litres. Okay, so 35 grams in 1 litre is 35 grams per litre. 35 grams dissolved in 500 ml gives you 70 grams per litre. Note that here we're not using our solubility curves because that only tells us about saturated solutions, where the maximum possible is dissolved. This is ways of calculating when it can be any amount that's dissolved. Okay, not more than saturated, but certainly it could be much less. If the mass is very small, then we might convert the mass to milligrams and then find the concentration in milligrams per litre. Now a milligram is a thousandth of a gram. So to convert from grams to milligrams, you would multiply by 1,000. Okay? If we've got very small concentrations, then we might do it in parts per million or parts per billion. So parts per million means you've got 1 gram of solute in 1,000,000 grams of solvent, or 1,000,000 litres, 1,000,000 millilitres of solvent. Okay? Parts per billion, a million means we got it in 1,000,000,000 litres. Okay, so 1 gram in 1,000 litres is, or 1 milligram per litre is the same as a part per million. We can also measure concentration as a percentage by mass. So a percentage of the substance in interest as a percentage of the total mass, or a percentage as a percentage of the total volume. So this would be how many grams of solvent or solute there is in 100 grams of your solvent. This would be how much of the mass of your solute in 100 mils of your solvent, or percentage volume by volume. So this is the volume of your solvent in 100 mils of your solute. So for example, if you've got 3.15 grams of limestone, okay, and we know that it has a mass of 1.87 grams of calcium carbonate in there, the percentage weight by weight, you would do 1.87 divided by the total mass of the substance, and that will give you a percentage of 59.4%. A volume by volume one, 1.8 divided by the total volume, because the volume of your methanol divided by the total volume of the solution, and that is going to give you the percentage volume by volume. Always remember to times by 100 when you're getting to the end there. The other way we can measure it is in concentration in amount. So the first thing you would do is convert it into an amount in mole. And that's where you get the molar solutions that you'll see published on them. So a 1 mole solution has 1 mole dissolved in 1 litre. 2 molar solution has 2 mole dissolved in 1 litre. Okay. Say you went back to your 35 grams of sodium chloride that we looked at before. First thing we would do is convert our volume into litres, and we'd convert our mass into amount in mole using the molar mass. So amount is mass divided by molar mass. You'd then use the fact that the concentration is equal to amount over volume. So our amount in mole divided by our volume in litres will give you our concentration in moles per litre. And we can do the same thing with any solution as long as we know it's pure and we know its molar mass. So we can go back the other way. We've got the concentration, we've got the volume, what amount in mole do we need? And then from the amount in mole, we can find that mass. Sometimes you're going to need to convert between units. These units are in your data book, so you can go from one to the other to convert them. Okay, so to go from grams per litre to mole per litre, it's the same calculation as going from grams to mole. You divide by the molar mass, because remember, amount is mass over molar mass. Okay, so if we've got concentration of 35 grams per litre, we can take that 35 grams, divide it by the molar mass, and that will give you the concentration in moles per litre. Okay. If you cut the mass units, then we can convert them. So parts per million is the same as milligrams per litre, so you don't need to convert that. But once you've got it in milligrams per litre, you convert that into grams, and then you convert the grams into mole. You've got to go through all those steps then. You can't go straight from parts per million to moles per litre. Parts per billion is just parts per million times 1,000. Okay? So you can go from that to parts per million, then to milligrams per litre, then to grams per litre, wherever you want. If you've got percentage mass by volume, that's the same as grams per litre. Okay? And if you've got percentage volume, then you can convert that if you know the density. So density is mass divided by volume. So if you've got the density, you can find the mass by volume, which will give you grams per litre. And then from grams per litre, you can convert to mole per litre if you wish. The final thing we might want to do with concentration is dilution. So if you've got a concentrated solution, you want to dilute it. We can use this as a two-step one. So we can say concentration is amount over volume. The amount is not changing, so we can do a two-step calculation. Or we can combine it by crossing out n, because it's going to appear in both calculations and it's going to be the same number. So we can say that the initial concentration times the initial volume is going to be equal to the new concentration times the new volume. So if the volume has increased, the concentration will have decreased, and vice versa. So if I've got 200 mils and my original concentration is 14 molar, I add 800 mils of water, what's my final concentration going to be? So my C1 is 14, my V1 is 200, C2 we don't know, that's what we're looking for, and our V2 is these numbers added together. So our C2 is going to be equal to C1V1 over V2, which is going to give us 2.8 molar. And we can do the same thing here. Potentially we might be looking for the volume. Okay. Be careful here that sometimes they ask how much water you need to add. So V2 will give you the total volume. You will have had your initial volume, so you need to subtract that to find what you'd need to add. Okay, because you would add 8.9 litres to 100 mils to get 9 litres.